Hello, I'm now going to talk about the development from a conceptual idea to actual hardware design for the optoelectronic output of the numbers. So this here is the shape of the digit as was explained in the other video, and the problem now that we have with using LEDs is that their light disperses in all directions. So in order to keep a distinction between the segments, we have to put gaps in the segments, such as there. So in my initial development I started to put gaps in, and I did that by taking material away from, or area I suppose, away from the smaller segments in the corners and at the in these locations on either side. But I then realised that that would probably be more obvious than if I took it away from the bigger area segments, because it's a greater percentage of that segment area being taken away. So that's then what I did with this design here, and you can see the gap. I then shrunk that design down to this size here, and this is the size that the actual digits want to be. So this component is 70 millimeters, 7 centimeters by 40 millimeters or 4 centimeters, and as you can see it's a 12 segment display there. So with the segments now the right size and with a spacing between them, that spacing there by the way is 1 millimeter spacing there. So then I moved on to the positioning of the LEDs, and because I'm going to be hand soldering these I chose to use 1206 LEDs because they're the biggest regularly available package size. That 1206 means it's 0.12 by 0.06 inches or 3.2 by 1.6 millimeters. So these boxes I just drew on as 3x2 mil for easiness, and then I tried to get an even distribution within each segment, so because they're point sources of light, so it would hopefully diffuse and get a constant brightness across the whole segment. So I've got 3 in these segments, 4 in that one which is an extra big one, and then a single LED for each of the smaller segments, and that amounts to 27 LEDs per number. And if I have them 5 numbers for 5 hymn numbers and 3 digits per number, that's 405 for the whole thing. So you can see that these things really do add up. So with them positioned, I then moved on to designing their power supply. So first thing to do is add pads around each end of the LED, so those were all added, and then I did the track around the outside which connects to one leg of each LED, and that's going to be the common, probably common cathode, because that's what's most readily available. And then I developed the power tracks, so connecting each of those for each segment together, and then I've just connected them to some pads which will be a connector, a through-hole connector, so I can just I'll have that as a dual socket, and then I can just plug a wire in and connect it up to a power supply. And these here are just for flying wires because it was difficult for me to route everything round, because I've been limited to using 1 mil wide tracks because it's going to be manufactured at school, and our PCB manufacturing is not very precise, and so we need about a 1 mil track for that to hold. So yeah, I've got the track layout there. To create the segments I'm going to have a piece of perspex with the holes for each segment cut in it, like you can see there, but I realised that these through hole components will be projecting up on the top side, so I put boxes around these and then incorporated those into that so that the piece of perspex can sit flush with the PCB. And I've also put holes in the corners so I can just use an M3 bolt to hold it all together. And from this I also extracted the plain PCB design for the actual tracks and added some text, and that's what will be manufactured in PCB manufacture process. I also then developed some other pieces, so this is a piece to go on on front of this one as an extra layer, so I can increase or decrease the distance between the LEDs and the diffuser material, so as I can experiment to see which is going to work best in terms of distance. And then these pieces are just to go on the back behind, so it gets a whole complete unit. So that's the development from initial concept of shape through to PCB design and a stencil in effect to channel the light into the correct shape for the segments, and then that will have a diffuser stuck on the top of it to hopefully get a nice consistent illumination to each part of the segment.